All right, so we should be on still chapter 8, and we are on the second question. And when we look at this one, we are standing on a roof and throwing a baseball up into the air, and the height of the baseball over time is represented by the graph below. And it says the height is measured in meters and time is measured in seconds, so we're going to answer the question below. So first, what do the x-axis and the y-axis represent? Again, the x-axis is your time. That is in seconds. And your y-axis is the height, and that is used in meters. All right, so starting for the first question, what is the maximum height? Well, actually, before we start with the question, just kind of pointing out the overall graph. So if we're throwing a ball from a roof into the air, I don't need this whole U. What I'm going to do is look to see where I begin, which is the y-intercept, which is here, and then this is me throwing the ball up into the air and then coming back down and stopping here. So this is the only part of the U, or a quadratic parabola, that we're going to be looking at. So the first question is, what's the maximum height and that the ball reaches? So again, I only need the height, and the height, the maximum height, is where I'm going to be looking right here. This is the highest the ball went, and I only need the height. So what we already wrote is that the y-axis is the height, so the y-coordinate is the height. So it will be 15.622 meters, and this point is known as the vertex. And then on B, at what time does the ball reach its maximum height? Then I'll look at the x-coordinate of the vertex as well. So 1.327 seconds. And again, this point is still known as the vertex. All right, there's a point on the graph with the coordinates 3 and 1.9. Explain what this point represents using correct units. So it's not one of the points that they marked, but it does mean that after 3 seconds, so I'm using correct units, the ball is 1.9 meters off the ground. All right, D, how long does it take before the ball hits the ground? So at this point, I'm going to be looking right here. This is where the ball hits the ground. And I know that because that is after 3 seconds, the ball has a height of 0, and 0 means it's on the ground. So the answer is 3 seconds, and this point is an x-intercept. And then moving on to E, what was the starting height of the ball? So the starting height, that's the same as the beginning, and the y-intercept, here we go, is always the beginning. So the starting height was the 7, because again, I'm using the y value for height, 7 meters. And this point, again, I already said, is the y-intercept. Okay. All right, moving on to the other one. So the graph is going to move a little bit out of the picture. So all of the function is defined for all real numbers. So what values of time make sense in context of the situation? So in other words, what's a reasonable domain for this problem? So domain, if you remember, is x. So I want the smallest x and the biggest x. And we've already gone through and highlighted the part of the graph that's important. So when I look at that, that is, again, this point right here, this 0, 7, and then an ending right here at this 3, 0. So what I'm going to do is just focus on the x value. So a reasonable domain is from 0, x or t for time, to 3. And you can even write 0 to 3 seconds if you wanted to do that instead. Okay, what's the average rate of change? So AROC, remember AROC is slope. Slope is just what we will be subtracting the y's over the x's of the ball over the time of its flight. So from when the ball left his hand, so that was 0, 7, to when it landed on the ground, so that was 3, 0. So I'm going to subtract my y's first. So I'm going to do 7 minus 0, which is 7. And that means I'm going to have to take the x's and subtract them as 0 minus 3, which is negative 3. And then I'll use my calculator, and I'm going to get that down to 1. So that wasn't a very good 3. And when I divide those, I get negative 2.33 over 1. So the reason why it's negative is because in the end the ball is going down. So the ball is changing negative 2.33 meters every 1 second. That's how fast it's moving or changing. All right, H. Approximately how long does it take for the ball to return to its original height? So remember, the original height is where it started at 7. So I need to go across to 7 right here and kind of estimate what I think that x value is. So it's somewhere, let me do a little racing here, in between 2 and 3, maybe a little bit more than 2.5 seconds. So about, I don't know, maybe 2.6 seconds. You could even say 2.5. And when was the ball 16 meters in the air? Well, the highest the ball ever actually got was up here, 15.622 meters. So this was never. Whoops. Never. The max height was 15.622. All right, let's move on to the next question. So now we are into chapter 9. And this was probably our longest chapter, the one where we had to remember the most. And this is, I believe our flip book was green. So, or it could have been gold. I'll tell you guys, you'll already have it out. So anyway, the first part that we talked about in chapter 9 was the 3 different forms of a quadratic: factored form, standard form, and vertex form. And that each point gave you, or each form gave you a certain point, and then how do you go from one point to the other? So since I'm using the computer to do this, just in your flip book, this is the top 2 boxes, the top left and the top right. So the first thing I have is standard form. So standard form, the key point that I get is the y-intercept, and that is just the c at the end. It's just this negative 20 that we're focusing on. So the key point that I get is 0, negative 20. It's the y-intercept, just so you know. And so now I'm going to get it into factored form, and I'm going to get it into vertex form. So for factored form, I'm just going to factor this. So I'm going to put my work over here, and I'm going to make my loop. So my factors of negative 20 that get me to 8, and I can use my factor program or my factor page, but I'm going to see that that is 10 and 2, and that the 2 will have to be negative. And now this is easy factoring. We introduced this. It's easy factoring because it's x squared. So actually, I can actually just go to my parentheses of x plus 10 and x minus 2. And now it's in factored form. And so what I get from here are the x-intercepts. And they are just opposite of the numbers that we see here. So negative 10, 0, and 2, 0. So remember, x-intercepts, x's are values, and the y's are zeros. And on y-intercepts, y's are values and x's are zeros. And now to get it into vertex form, I will have to complete the square. So what I will be doing is grouping my x's. It's ready to go because it's x squared. And I will be adding a blank and subtracting the 20 that's there and subtracting a blank. And I'm going to take this 8, I'm going to cut it in half for 4, I'm going to square it and get 16. And it is 16, it's not changing because there's not some number outside here that's affecting the 16. So it'll be 16 here. So what's going to happen is outside, I'm going to simplify that down if you want. I mean, you're going to have a calculator, but maybe you want to add the opposite and add the opposite, and then you'll see that it's a negative 36. And then in my parentheses squared will be x plus this number, and it's a plus because it's a positive 4. And now the key point I'm going to get from here is the vertex, and the vertex is opposite this h, and this one as is, whoops, negative 36. Well, let's just erase that. Okay, going to number 2. So this time I have vertex form, and I will be getting the vertex from there. So it's going to be, okay, so sorry, I had to pause. So again, in this one it's in vertex form, so I can take the vertex, and I'm going to take the opposite of this number, And I'm going to take this one as it is. Again, I'm just using the top right boxes of my flipbook. So that's the vertex. And now I'm going to get it into standard form and vertex form. So if I look at my flowchart, I have to get it into standard form first. So I'll be moving here, and I'll be looking at this x plus 1 squared. I'll be looking at it as 2x plus 1. So there's an x plus 1, there's another x plus 1, and then I'll still have the minus 4, but I'm going to have these neighbors meet first. So x is going to go visit first, and I'm going to get x squared and 1x. And then 1's going to go meet the neighbors. I'm going to get another 1x and then a 1. And then I'm going to go ahead and put that minus 4 and stack it with its like term. And I'm going to add these up. So x squared and 2x and 3. And now that it's in standard form, I can look at the end and get my y-intercept. And it is going to be 0, 3. And now that it's in standard form, I can take my standard form and I can factor it. So again, making my x, I need the factors of 3. They get me to 2. Oh, and you know what? I actually messed up. I need to come back over here. When I added these, I said it was 3, and it's actually negative 3. So that's going to change my y-intercept. So that will change it here to negative 3, and it will change this to negative 3. So factors of negative 3 that get me to 2 are 3 and 1, and I'm going to make the 1 negative. And again, this is easy factoring because it is x squared. So I can go straight to my factors of x plus 3 and x minus 1. And now my key points are one x-intercept of, take the opposite, negative 3, 0, and the other one, take the opposite, and it will be 1, 0. All right, moving to the last one of this part. So in this one, I start with factored form. So again, I'm going to go here, and I'm going to get my x-intercepts first. I'm going to take the opposite and do negative 1 with 0, and do the opposite here of 3 with 0. And now I'll get it into standard form, which means I have to go to this one next. I don't have a choice, which means I need to have some neighbors meet some neighbors. And we agreed that when the neighbors were going to meet the neighbors, that we would always start with parentheses. So starting with my parentheses, x is going to go visit, and I'm going to get x squared minus 3x. And then 1's going to go visit, and I'm going to have 1x. And then it'll visit this, and I'll have a minus 3 or a negative 3. So when I add these up, I get x squared minus 2x minus 3. And I don't want to forget about the other neighbor. 2 now needs to go and meet all of these. So I'll get 2x squared. 2 will meet this, and I'll get minus 4x. And 2 will meet that, and I get minus 6. And now that it's in standard form, I can look and I can see my y-intercept. And it is 0, negative 6. Again, y-intercepts, y's are the number. And then the last one, I'm going to take my, and now I'm going to take my standard form, and I'm going to get this into vertex form. So again, I'm going to have to complete the square like I did on the first one up here. Now in this one, this was ready to complete the square because it was x squared. This one is not ready because when I group my x's, it needs to be x squared. So first I'm going to take a 2 out. So taking a 2 out of both x's. And now I'll put my blank, and then here's the minus 6 and minus a blank. I'm going to take this number, I'm going to cut it in half, that's negative 1. I'm going to square it and get 1, and 1 goes here. But remember, it's not really worth 1 because in the end, this 2 is affecting this 1. So even though I wrote 1, it's really worth 2. And this 6 actually did not turn out very good there. So now I'm ready to clean this up. So outside, over here, if you want, you could add the opposite. And you're going to see that you're going to get a negative 8 or minus 8. And then in parentheses squared is going to be the x plus this number. And then hopefully you don't forget about the 2. It goes in front. And now my vertex is the opposite of this as 1. And this one as it is, and negative 8. And that is that page. And we'll move on to the next one.